Alright guys, so what do we have here today? We have two Google Pixel 4 XL that was given to me by another technician. This phone is coming from another repair shop. Now the problem with this phone is a display issue. Now the Google Pixel 4 XL is very notorious for this display problem. As you can see right here, the phone is actually on. If I press, it's going to vibrate, but you won't see it. So let me try and plug it to the charger so you see. If you see right here, it's connected to the charger, and the phone is practically on. You see it's taking 1.0 amps, which means the PCB is fully on. Now this other PCB, the technician gave it to me like this without a battery, but if the repair is successful, I will use the battery of this to test the PCB as well before we proceed. So let me go ahead and dismantle the phone and let's proceed right away. So I'm going to use my preheater right here. You see this is a preheater from Louis. This is a temperature, can set up to 130 degrees, so I'll just leave it at 100 degrees and I press start. When it indicates the red light means it's on. So I'm just going to drop this here for a little bit of time for it to practically warm off before I can remove the back. Now, one thing I want you to know is these Google Pixel devices are very notorious for this black display, and I've scoured through YouTube channels and I haven't found a single technician that have done this repair. But like I always say, these Google Pixel phones are the reasons why I took up micro soldering and advanced repairs, mobile phone repairs, because I had a lot of them on my desk each day. At times I had to sell some of the motherboards which had just little issues and I did not know how to go about it, so I took it to myself to study so I can solve such problems rather than just selling out the PCBs. So we are going to return back to dismantling the phone once it's heated up right there. So I'm going to keep this one aside while we work on this. Now, like I said, this phone is coming from another repair shop and they had already done their diagnostics and tried other screens and concluded that the PCB had a display problem. So I'm just going to go ahead and unscrew the phone right here before we continue the repairs. Alright, so the PCB is finally out. If you take a look, the PCB is untouched. It has not been touched before. So let's begin with the battery. Let's take a quick test on the battery to see how many volts the battery has. The battery is at 2.4, which means it's a bit low. It's supposed to have about 3.7 volts in order to be sure that the battery is okay to use for work. So I'm going to activate the battery again. Alright, so I'm going to leave the battery to charge while I take a look at the PCB. Okay, so now first we are going to rush to the Orion schematic, and we are going to click on the AMOLED section. Now we have two very important lines here that we want to be checking and making sure all the readings are okay. So we have the VREG ELVSS, which is a negative line coming directly from the AMOLED IC, and we have the VREG ELVDD, which is a positive line. Now these two terminals, these two lines bring in the positive and negative voltage into this battery, into this screen connector, which then powers up the display. So if any of this line has a short or there is an open circuit, we might not have a display. So let's trace let's trace these lines and see where they head to. If you see the ELVDD, which is a positive line, takes its readings from this AMOLED IC right up here, and even the VREG ELVSS takes its readings from here as well. So if there is any short on this IC or anything along this rail leading to the screen connector right here, we are probably not going to have a display. So we are going to first of all start by checking the diode voltage drop, which is the most important thing to do. Now I'll let you know this for once and for good. When you are working on any device that has a problem and the component you are working on has an FPC connector, the first place you're going to start is from the connector. First off, you're going to check the diode readings if they are all okay, and compare to maybe a non-good board that is working. So you first check if the diode readings are okay. If you get maybe a short on a line that is supposed to be giving you voltage, the only thing you have to do is to trace that line to the source to know if the problem is coming from along the rail or from the IC that sends in the voltage into the display section, or the maybe camera, I don't know, any stuff, any sort of any component that connects through an FPC. Because first off, these diode readings here have to be correct before you can expect the component to work. So let's go to diode voltage drop. If I click on the diode voltage drop, now you see if we take a measurement on this part with our multimeter on diode mode, we are supposed to get all these readings as they are or close to it. If we get anything lower 0 or OL, means that's an open line. means there might be a break in the line along the way, or maybe if we get a beep on a certain component that's supposed to be giving us a value, means there's a short on the PCB or on the rail. So now let's head to our PCB and check this 1, 2, 3, 4, 5, 6. These 6 lines are the lines responsible for the positive and negative voltages that get into this FPC connector. So on the first track here, we are supposed to have a 1.04, 1.04, and on the third 1.02, it's all the same. And then we need to have 0.7, then we head to 555. So we have to check this 1, 2, 3, 4, 5, 6, 7 tracks to see if we have a good reading there first of all before we proceed. So I'm going to zoom in a little bit so we see very clear. For my multimeter, I'll set it to diode mode right away. Okay, you will see right there it's set to diode mode. So now this is the part we're talking on. We have this 1, 2, 3, which is the ELVDD, which is the negative rail that brings in the voltage into this line, and we have this one which is in the middle, and then we have this 1, 2, 3. If you check a look right here, if you can trace tracks, you will notice that all of them are found on the same track. If you see this 1, 2, 3, they are all found on this track and connects to this component here. This one connects to this, while these other 1, 2, 3 are connected to these components right here. Alright, so now let's go ahead and test and see the values we are going to get. Now these first 3 tracks are going to give us a value of 1 point something volts if the line is okay. If we get anything less than that, or OL, means there is an open circuit within the line. So let's go ahead and check. We have a value of 1.0, which is okay. This is another 1.051, and this is, so the negative part is alright. Now let's head to the positive side. This is supposed to give us 0.76 something volts, and now let's head to the positive side. If you see, the positive side is giving us a value of 0.00, 0.00, 0.00. Practically, this tells us that there is a short on this line. As you can see from here, we are supposed to have a value of 505 or 0.507. If you take a look right here, these are the 3 parts. This is the positive side, so we are supposed to have a value of 0.507 on these 3 parts. So if we are getting a value of 0.001, that's a short. So now let's test again, just so you see. We have these 3 tracks right here. If we click here, we have a value of 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 1. And if we test these other components, they are going to be giving the same values because they are all connected on the same track. Alright, now let's go to buzzer mode to confirm that this is a short. Now normally if this is good, it's not supposed to beep. So if it beeps, it means there is a short on this line. We already confirmed from the diode mode. Now we are confirming with the buzzer mode. You hear that? That's a short, and that's a full short. So now from From my experience on another Google Pixel I was working on the other day, that I solved a similar problem. This track, this is just a bonus tip. Working on these PCBs that don't have bit mapping, you get to discover things on your own. So I discovered the other day that these tracks right here are connected to these are the tracks that are shorting. You have this, the ELVDD is connected to this resistor and this capacitor. Now if we head to this other side of the PCB where we have the power manager ICs, this particular component you see right here is connected to that rail, to that positive terminal, to that positive line that enters the FPC connector for the display circuit. So this capacitor right here, this particular capacitor is connected to that rail. So now when I injected voltage on the other phone that had a similar problem, I discovered that this capacitor right here was a shorting component and I had to remove it. On removing it, I discovered later that this IC was also bad. I don't know if it's due to the short that killed the IC, because once I removed the short, the values were back, but the values were not correct. The values were incorrect, and now this other line, the VREG ELVSS, which is a negative line, was not giving any value. You were showing OL. But for this one now, we checked and we are getting a value, the correct values from these 3 pins, and these other pins we have a short from here. So I'm going to open up the other section of the PCB, spray the rosin flux around here, also spray the rosin flux around this capacitor and this AMOLED IC right here, and then inject voltage from it. So let me go ahead and peel off this shield. Now this is we are working on a display problem which is proving to be a short circuit problem. Now I cannot go about and start heating up this shield to remove, because if I heat this shield up to remove, we might end up with an open circuit, and you don't want to have an open circuit with Pixel devices, because they are very complicated, as you can see. Very, very complicated. Very, very complicated devices when it gets to ICs, because the way they apply the black glue on their ICs is very difficult to work with them successfully. But I also realized that when you cut off this shield, it comes off easier than when you even heat them up. So preferably I'll be cutting off the shield rather than heating it up, in order to be on the safe side. If I knock off a few components, I'll be able to replace them back. But if I end up with an open circuit, I might end up not being able to repair this PCB, which was given to me just for a display problem. So it's good to work on the safe side. Be safe, and also make sure you maintain the safety of your client's phone. Now remember, mobile phone repairs is a job that you need to love, because it's like taking a profession. For being a doctor, you need to love that profession first of all. You don't go into the profession of bringing people back to life without loving the job that you do. If you are just all about money, you will not be a professional in what you do, because at the end of the day, you will not be looking at bringing back a smile on people's face. You will just be about filling your pockets. So before you take on a client's phone, don't just look at the benefit you're going to get after the job. Also make sure you do your client's job very well, so that they can be happy as well. Alright, so now the PCB is, I've removed the shield. I think I did not knock off any capacitor. Everything is intact except this tiny one right here, which is a bit, well, this is no problem. I can replace it. I'll fully fill it back in place. Alright, so if you take a good look right here, this is the capacitor we're talking about. So sorry, the diagram was covering. So this should be the only component that I almost knocked off. Every other thing is intact, and this a minor twist which I can adjust later. So if you take a good look, this is the capacitor I was telling you about that is connected directly to this pin right here, these three positive pins right here. So we are going to test this capacitor just for you to confirm that it is linked to that same line. And also I'm going to test the continuity from this capacitor right up to the FPC connector. So let me test now. We confirm that it's shorting right. Now this phone doesn't have a bit mapping, but I discovered this because on solving a problem of display of this same phone the other time, I discovered that when I injected voltage from the other end, this capacitor here was the one that melted off. That's how I realized that this component right here is directly connected to the FPC connector. Okay, so now I'm going to test the continuity from here to the FPC connector, so you confirm that it's truly connected. Now I've placed one probe on that capacitor, and this is where we are. You get the beep right. This shows that that line is totally connected. All these components are connected to it. So now what do we have to do right here? We are going to spray our rosin flux and then inject some voltage. Like I told you, since these components here are connected, we are going to spray the rosin flux from here. We are also going to spray around this place and this IC. I think that's enough for that area. Now let me spray this other section. Okay, I think that's enough too. Okay, so what I'm going to do is I'm going to hook this black alligator clip to any of this shield because it's going to serve as the ground. So let me see, I'm going to hook it right here. Yes, and then on the other end, which is the positive side on the alligator clip, I'm going to hook up to my multimeter probe. So I'll use to inject because it has a tiny head. And now on here, I'm going to use a 1.8 volts, and I might set up to about 3 amps right here. So now let's watch first of all if we are going to get a reaction from this capacitor right here, this one. So I'm going to be injecting from down here. You see the consumption, right? See the consumption is consuming 0.8 amps, and if you check a look right there, that capacitor has totally melted off. Now I'm going to zoom in again so you see, and I'm also going to apply some more flux there. Now I'm going to reduce the amps to about 2.5 amps so it tries to melt off gradually. So you take a look at the DC power supply and the screen right there. You see how fast it melts off, right? So that is our bad guy. What we have to do next is to take him out and then recheck for values on the connector to see if the values are back or not. So you see one tiny stuff like this can end up destroying the whole PCB. One tiny capacitor like this. Last time I messed up the same capacitor right here. I think next time if I have to do such a repair, I'll just go ahead and use the heat gun to remove it. So now let me bring in the capacitor right here and let's check. Alright, I think that is okay. So let's check on booster mode to confirm that this was shorting. You get the beep, right? Okay, so now that we have removed this short, what do we have to do? We need to get back into checking these components right here to see if we have the values back or there is still another problem. Remember, those are the positive and negative lines of this FPC connector, so without which, if there is any problem there, we might not have a display on this phone. So now let's give it a test one more time. We take a look at the multimeter right there. Now let's start. We have a value. 700. Now here we're getting a beep before. Let's see if we have a good value. You see, like I told you, we are having a very bad value right here, and this can only lead to the problem coming from the AMOLED display. So it shows that when this capacitor has a problem like this, okay, now the value back here is back fine, even this one, even here, good. And here you see we have a very low value. We have 119. What this tells us is that due to that short, it might have affected the AMOLED IC already. That is the only reason why we are getting this low current, reading from this particular part right here. So I'm going to give the PCB a good clean and then remove the IC, clean the parts, then prepare it for a donor or IC. That is the only steps to take because those are the only components that are connected to this display, as you can see right here. So once, like I said, we start by tracing from the connector. If we get incorrect values here, we head directly to where that connection is coming from, which is from the IC. Now this component was shorting right here. We remove the component and now we have irregular values, so which means the problem is coming now from this IC, and I don't think reballing will solve the problem. So I'll just go ahead and pull off a donor IC from another PCB and use. Okay, I think that is set. So now I'm going to start first of all by cutting off this glue right here. There is a glue here, so I'm just going to cut it off first before I proceed. It is very important to cut off this glue, because if you don't, when you want to pull out the IC, it's going to come off with this component right here. As you see, it's already coming off even. This one is no problem at all. I'll replace it later on when done. When I'm done, I can replace it. So I'll just pick it up and keep somewhere else. I think that has fallen off. Well, that is no problem at all. I'll have to get back to it later on when we are done with the repair. So next thing, we apply flux, which is very important. Now my rework station is a rework station I just recently bought, so I'm still getting the heck of it. So I'm going to set about 475 degrees of heat, and I'm going to set the air to 30, I think 28% will be okay. Yeah, 28%. So you have to heat for a period of time before you try to pull it off. Now this IC has some black paste under, the black glue under, so you need to take very good care not to peel off the parts under. So we are going to heat. At some point when I heat and as I see the solder ball bulging out from the edges, then I know it's ready for me to take off. So we are going to apply the heat on the IC. I think the IC is off. Well, as easy as that. Now, for what I've noticed about this IC, when you're heating, once it's off, it just like trips, it just kicks off, and you notice from the area you're working on. So now I'm going to be using my soldering iron, and I'm going to set the heat to about 450 degrees, and then I'll apply some low melt flux for right here to blend the parts to it. Now this process is very important because you don't just want to go ahead and start scrubbing these parts off with force. You need to do it carefully. You don't use force. Remember, I told you this IC has black paste underneath, so you need to apply your flux at some point. The flux is the only thing that makes these things come out very easily, so you need to practice to always work with your flux when doing such repairs. Alright, so I'm going to add some more flux, then I'll get my desoldering wick. So now when doing this, you don't have to apply force since you have already blended the parts with the low melt solder paste. You just need to push through and it rolls through the parts. Now I'm seeing one part here which looks oxidized, but you just need to re-clean, add some more flux. When doing micro soldering, I keep telling you the flux should be your best friend. The flux should be your best friend. It can save you in any situation. So right now we are going to clear off this residual glue. As you can see, some of them right here. You see these edges, right? So some of the extra glue here that we need to clean off. We need to be careful not to scratch these parts, which can leave tracks that can cause solder breach under the IC. And you also need to clear off this excess glue right here, so that when you put the IC, it's going to sit very flat. Now if it doesn't sit very well, possibility of it not having a good connection with the part is about 80% already. So you can do a good job and end up redoing it simply because these things were not aligned and the surface was not flat. You see right there, this is a breach right here that has been caused by the flux, by the solder paste that we're using. That is how easy the solder paste can cause such issues. I'll use the solder wick to get it off. I'm thinking I should repair this component that came off before I proceed with the IC, just in case, to avoid heating up after I've already mounted the IC. Door numbers right here, so I don't even stress that much when I'm doing these jobs. I have a lot of them. So I'm going to just take off one from here because the other one fell off while I was trying to safeguard it. Instead, it instead fell off. So I'm going to be taking off this one right here to replace. think that should be okay. There is another solder bridge right here. That's why it's important to make sure you pick off all these little solder paste before you even start heating up, because it can cause so many breach. Now if you take a look here, this is another solder bridge right here. I'm trying to be as careful as possible not to cause any damage right here. I think that is, the bridge is off. So you see the parts are well clean. I'll just clean it one more time. One final clean. Now everything is clean. I'm going to keep this one aside, and then I'll go ahead and get my donor board, where I'll pull out the IC. And mind you, I'm not just going to pull out the IC without testing the diode values from the FPC connector to see if they are all giving good values. So we are going to check this PCB if the readings are okay before we go ahead to remove. Alright, so now let's test. That's a good value, that's a good value, that's a good value, that's a good value. And you see, right, that's the value we're supposed to be getting, close to 500, close to 0.500 volts. So this tells me that this AMOLED IC on this PCB is fully okay. So I'm going to cut off the shield right now. It's funny how when you even remove this shield because you want them to even get damaged, it doesn't damage anything, but when you want to remove them safely, they start pulling off capacitors here and there. So I'm going to be using this other PCB, this other PCB holder right here. Okay, I think that is okay like that. Now let me cut off the glue first before proceeding to heating up the IC for removal. Like I said, it's very important to cut off this glue before you start heating, because if not, it's going to come off with all these components. So you just have to be technical about it. You apply the heat and then you cut through. Okay, so before I start heating this stuff, I want us to do one final test. Let me cool it off first. Okay, so now let's test that other capacitor that was shorting on the other PCB and see. This is a capacitor right here, this one. So let's test to see if it's going to give us that value we had on the positive line. You see, we have the value right now. You confirm that this capacitor is truly linked to that line. So anything that goes on with this capacitor is going to affect that line right down there. So I'm going to apply my flux. And I'm going to bring in my air gun. So I've set, these are my temperatures I've set. I have 35% air and 485 degrees. So like I told you, I'm still struggling to understand how this heat gun work. You don't need to follow my parameters. You need to understand your own heat gun to know it's your heat gun may be hotter than mine, so we cannot use the same parameters. You need to pay attention to that. So we are going to start heating, and like I told you, when you heat up to a certain level, it's going to puff up like that. That's when you know that it's ready for you to remove. So you don't need to pressure it. You need to make sure it comes off on its own so that you don't get to damage any part under the IC. Normally when the air has gone under, you see the flux will start flowing from under, or you see this, while you see all these solder balls that are coming out. This tells you that the IC now is ready for you to remove. You can start trying to pull it off, but not applying force because you want it to come out safely. This is an IC that we have to use. I almost killed it right there. Oh, thank God it didn't come out so badly. That is the IC. Well, I may have knocked off a few components here, but this is a donor board, by the way. So I'm going to get my PCB holder, the one I use for ICs, and I'm going to place this IC right here. So first, I always apply flux. Remember, there is still glue on this IC, so you want to clear off the glue first. Alright guys,
So in this part of the video, I'm currently doing a voiceover because this portion of the video was very long, so I had to edit and trim some of the section and also increase the speed so that the video will not be as long as it was. Now, right there I was going through to check the stencil that I was going to use to rebuild this IC. Normally the original stencil of the IC was present, but because I was trying to fight against time, so I went ahead and picked up the wrong stencil, which could still do the job, but due to the fact that I made a single mistake and did not apply the adequate heat and temperature, the IC could not fully rebond and bond the BGA to the bonding parts. Now you need to make sure these parts are really clear, like there is no glue left under this IC, because if the IC cannot sit flat on the surface, it might not have a good bonding with the parts under the IC. So it's very important to clean and make sure everything is set. Now next thing, since my stencil was really clean, if you take a look right, that's not the adequate stencil for the IC, but I just had to use it. I could still use it to do it the job perfectly, but just a single mistake. I left one line of the IC parts that did not fit into the squares right there, so I had to redo the IC again with the real stencil. So right here, I think the heat that I used here was 375, and I used airflow of 20%. So if you take a look right there, the IC it bonded really well, except the other line that was not fully aligned in the square, because when dropping the stencil, due to the fact that I'm using a magnetic reball plate, it just clipped off the stencil and I thought everything was okay. If you check the top of the IC right there, you see this down period, this down section, you see there's one line left there that was not reballed. The ICs, the parts, the BGAs do not bond with the part because the IC, the stencil was covering those parts. Now next thing I had to do was just to do a quick desoldering with my desoldering wheel, clean it off and reball the IC again one more time, and this time around being very careful not to make a mistake again. Now I made a mistake the first time because I was in a haste to look for the real stencil for this, but later on I had to take my time to go through my stencils. Now with Android phones, you need to be able to use the universal stencil because I use it most of the time, but the only reason I had a little difficulty here was because my workstation is a new workstation that I just bought recently, so I'm still trying to master the heat of the heat and air and air settings of the workstation. That is why I have not yet fully mastered it. So even right now I'm facing some little difficulties reballing with the universal stencil, especially for ICs like this Qualcomm and if I had a CPU to reball. But practice makes perfect. I believe with time I'll get to understand the workstation very well. Now if you take a look right there, that was the real stencil for this IC. Now reballing with the original stencil of the IC gives you at least 95% chances of doing a one-time reball and doing a perfect reball, because if you don't master how to use the universal stencil very well, you face difficulties while reballing certain ICs. So you need to apply your solder paste right there. You need to dry it off. It doesn't need to be too dry or too wet, so you just need to dry it off just as much as needed. So you apply the stencil and you use your tweezers to just hold down the stencil. You don't need to press actually, because if you press, the air is not going to circulate under the IC. You just need to support the IC so that it doesn't move while you're heating. And right here I have to increase the heat temperature to about 385 degrees, and I use 27 degrees airflow. That is why the reballing was a bit successful. And also due to the fact that I used the original stencil for this. That is why the chances of it coming out perfectly was really easy. Now after any reball, as soon as you remove the IC from the stencil, the next thing you need to do is to apply some flux and do a one-time reflow so the BGAs bond perfectly to their bonding parts on the IC. That is how you do it.
Alright guys, I had to pause the video to do this special part of the video. This is very important. Now I want to let you all know that it is not just about providing solutions without understanding the problem. Now if you notice on most tutorial videos online, when a technician is faced with a particular problem, he just go about and watch videos and fast forward to the end to see what was done to actually get the good results. Now you fast forwarding the video at the end without getting the full explanation of what the technician actually did is very detrimental, because you can go ahead and follow the same step that was used in the video, which your device doesn't need the same steps. Now you need to know and understand how to troubleshoot and interpret readings, especially with your multimeter and your DC power supply. Now you can have 4 PCBs in front of you. All of them have the same problem, no display, but you can't believe that the 4 PCBs will have different approach or different solutions to the same problem. Now if you understand how the multimeter diode readings work is very important, because you can know that if I'm expecting to receive this particular amount of ohm reading at this connector and I don't get it, I have to trace that part to where it's actually coming from, maybe from that part to the IC. Now you don't just go about watching videos and you go about copying solutions without actually testing. Now I can have a display problem on this Google Pixel 4 XL, which had 2 problems. Now the ELVSS line was shorting, which we cleared the short, and later on we discovered that the PMIC was also the problem. Now on another PCB, as you will see in my next video, the other Google Pixel 4 XL that I had, I remember at the beginning of the video I said I had 2 of them. The other Google Pixel 4 XL had just a short on the ELVDD line, just a single shot. Once I removed the shot, the display was back. Now if you go ahead and say, okay, at the end of the day, on my previous video I just remove this IC, pull out the donor IC and reballed and put, and everything came back, and you go about and do the same thing, you might end up killing the phone, because you did not actually know exactly what you were doing. You just assume that, okay, you have watched 2 or 3 videos and this was the same thing that was done by the technician, so you just go ahead and you swap ICs without getting your readings to know where the problem is actually coming from. So as a mobile phone technician, endeavor to understand your DC power supply readings and the multimeter reading. It is very important. The multimeter is what tells you which component is good and which component is bad, and it also leads you to know the direction of troubleshooting. That was a very long process. So whenever you're done reballing any IC, you need to make sure you do a reflow so the solder balls sit very well with the parts. Now let's give it a brush. Had to take a few pics there that I will use for the thumbnail of the video. Alright, so now we are going to apply some more flux here. I think that should be enough. Then I'm going to heat it up a little bit and then spread it throughout the entire surface. So now the next thing is to align the IC. We need to align the IC. Now this is how the IC sits. Alignment is very important because if you don't align it, once you start heating, the IC will slide off and maybe form a solder bridge. Yeah, I think that is okay. So now I'm going to reduce my airflow to 20 and maintain 380. Now you're going to notice when it's time for the IC to set, it's going to melt and go down. That's because we are using a low solder melt and there's flux under this IC as well. So you just need to heat gently. You don't apply too much flux and you don't apply much heat as well. So I'm going to add a little bit of flux right here. All right. Now we don't want to heat for so long because there is the CPU behind this area. So I'm going to nudge it a little bit. Yeah, that shows it has bonded. So we allow it to cool off a little bit. So I'm going to try and cool it off faster. Alright. So now we are going to get some diode reading right here before we proceed to testing. So we are going to test from here and see if we have a value. We have a 459. Good. This sounds really great. Now let's go back to our connector right here and test. Okay, so now here we have a value of 1, 1, 1, 0, 1, 1, 0, 1, 700, 4, 5, 4, 4, 9, that is 500, that is 0500 volts right there. Guys, I think this repair is successful. So now let's go ahead and give it a test. let's give it a full test. So guys, I think I just found the problem and the solution to Pixel 4 XL with no display, because this is practically not the first one I've done. This is the third one I've done, and each time, no matter how much I troubleshoot, I always end up with replacing that particular AMOLED IC. So it shows that the IC easily gets damaged either by a short circuit or probably an open circuit. Now the reason why I didn't reball the old IC to replace is because since the values that the IC was giving was not okay, I didn't see any need for reballing. If it was probably showing maybe open line like OL, yes, that I would go ahead and reball. Maybe there was just a solder disconnection. But for the fact that it's showing values and irregular values, reballing wouldn't solve the problem. That is why I had to just pull off the IC from another doorknob. So now 100% sure this phone is supposed to turn on and give us a display, except there is another problem on the PCB. So I'm going to drop it right here, and I'm going to take my charger. So now let's plug. Good, that's an image right there. Guys, this work is really nice. It's showing battery okay, 88%. Now if you check here, you see. So let me power on the phone. Let's test together. This is so good. Well, it's good to study because I've found a solution to these problems on my own. I didn't watch any tutorial videos. Wow, as you can see, and back to life, 100% active, back to life. Pixel 4 XL display problem solved. So like I told you guys, you need to have the passion for this work in the first place. If you don't have the passion and you don't have that zeal to excel, you're just looking at money at the beginning. You're not going to see the bigger picture. Equip yourself first of all with the knowledge, have the ability to do everything. Now when you sit and start working, you see the money flowing in. If you have watched this video right up to this extent, I believe you have learned one or two things from my explanations. They might not be accurate, but at least you saw everything I did on the video. And thank you guys very much for always supporting, for commenting, liking and sharing. Please make sure you click on the notification bell, so each time I drop a new content like this, you get to be notified instantly and you get to have the privilege to watch it one of the first people. Stay blessed. Thank you once more.